As you might have intuited from the exercise, some more cleverness will be needed to make this process efficient. Even the evaluation of polynomials at arbitrary points will take quadratic time. For each point, we need to do a number of multiplications and additions that is proportional to the number of coefficients. The most efficient way to do this is via Horner's rule. You can find a link in the instructor's notes. You can also think about filling out the Vandermonde matrix and then doing the matrix multiplication. Regardless, for arbitrary points, we end up with a quadratic running time. Multiplying in the value domain takes order n plus n time, since we just multiply the values for the corresponding inputs, xj. This part is fine. Interpolation involves solving a system of equations with n plus m equations and n plus m unknowns. By Gaussian elimination, this would take order n plus m cubed time in the worst case. For Vandermonde matrices, however, there's also a method called Lagrange interpolation that allows us to do this in time that's just quadratic. Note, however, that this still isn't good enough. In fact, we're at essentially the same running time as we have for convolution. Is there any hope? Well, yes, there is. All of these running times pertain to an arbitrary set of values for x here. But since we're only interested in the coefficients of the product polynomial c, we get to choose all these x. And as it turns out, this freedom is very, very powerful.